project.
Thanks, Elise. I'm Rhiannon Bazor. I'm the Coastal Shore Specialist with the Oregon Coastal Management Program, which is housed within the Oregon Department of Land Conservation and Development. As Elise mentioned, I'm also the co-coordinator for the Oregon King Tides Project, which is currently in its 14th year. And every year we ask participants, anyone who is visiting the coast or lives on the coast or has any interest in the coast, to very safely take photos and upload those to our to help document what sea level rise may look like in the future. With these images, we can really help our scientists and our city and county planners and state planners have an idea of areas that may be hit hardest by sea level rise, areas that are already prone to flooding and to high erosion events. And so it's really a great opportunity for community science, and it's also a really good opportunity to get to the coast and see some really exciting impacts from the king tides. And so the next set of king tides are from December 13th to the 15th. We're already seeing some pretty high tides right now, and we'll continue to see them beyond that as well. But the highest tides will be from December 13th to the 15th. So keep an eye out on all of our social media pages for highlights from those events and opportunities to submit your photos to our website, which we'll drop in the chat, which is OregonKingTides.net. With that, I will go ahead and introduce our guest speaker tonight, Dr. Peter Ruggiero. Dr. Ruggiero is a professor in the College of Earth, Ocean, and Atmospheric Sciences at Oregon State University. His primary research interests include coastal geomorphology and coastal hazards, and he has over 2 decades of experience in assessing the impacts of storms and climate change to beaches and dunes. Currently, his research group is developing probabilistic approaches for assessing vulnerability to coastal hazards in light of a changing and variable climate. He currently leads several transdisciplinary projects that are assessing coastal resilience and ecomorphodynamics in the U.S. Pacific Northwest as well as elsewhere. He is a principal investigator as well and co-director of the Cascadia Coastlines and People Hazards, I cannot speak tonight, I apologize, Research Hub, or COPES Hub, which is a multi-institutional NSF-funded project focused on increasing resilience among coastal communities in the Pacific Northwest. So thank you, Peter, for joining us tonight and telling us a little bit more about your research.
Right, can you hear me okay? Excellent. All right, thanks everybody, and thank you so much for having me tonight. It's a real pleasure to be here and to be part of this this webinar series. Let's just start with some kind of large-scale ideas about what to expect kind of globally from climate change around the world. But as I'm doing that, I'm going to show a couple of videos from the Northern Oregon coast that have been taken over the last couple of years. Scenes that many of you might be familiar with during king tides and some of the bigger storms. But there's some indication that globally flooding it might be projected to be doubling every 5 years over the course of the century, this coming century, due to sea level rise. There's some estimates that by 2060, over 1.4 billion people may be living within the 100-year hazard zone globally. And then there's other estimates that say by 2100 at the end of the century, and this is a lower order of magnitude, but still a very large number, 17 to 72 million people may be forced to migrate globally away from coastal regions. And so these are very dramatic numbers, a range of different kinds of methods and studies. But we know along the Oregon coast that we have these kinds of problems now that I'm showing here. And we want to understand what's going to potentially happen in the future and the kinds of things that we can do about it. And that's the kinds of things I'm going to be talking about tonight. We also know that along the Oregon coast, we experience not only those high water level events that can overtop and cause backshore flooding, but we also have chronic coastal erosion of our coastal dunes and our coastal bluffs that cause problems when there's infrastructure behind those those shorelines. There's coastal landslides along the coastline intermittently in a variety of areas, causing problems to transportation corridors and other infrastructure, et cetera. And all of these issues that we're already experiencing now along the Oregon coast have the potential to potentially get significantly worse with climate change. And so the primary climate change drivers that are going to potentially modify coastal community resilience to flooding, erosion, and landslides are things like sea level rise, variability in our ENSO patterns, and trends in variability in storminess patterns. And these are the kinds of things that we've been trying to quantify along the coastline and to see what might happen over the course of this century. And so I'm going to start with just some kind of global data here. This is data that's been collected from the satellite record of what sea levels have been doing everywhere. They've been actually rising over the course of the last several decades on the order of only 3.5 millimeters per year. But even with these relatively modest increases, if we just let those rates that we're experiencing now increase to the rest of the century, that's still just a foot of sea level. That's already a foot of sea level rise. And if we take into account the acceleration that we've observed in the last couple of decades, that's this green line. And so these are projections of sea level if we let the linear trend go forward, or if we let the accelerations that we've already been experiencing go forward. But that's not the whole story. We also know that based upon the emission scenarios that we kind of tackle globally, we're going to have a wide range of potential sea level rise into the future. And that's what this plot on the right shows. It's shown here in meters, but there's a wide range, anywhere between about 0.3 meters to well over 1.5 meters. And that, in feet, that's over from about a foot to about 5 to 6 feet is the range of possible sea level rise futures we have over the course of the century. Now, there's probably a good chance that we'll be somewhere in the middle, but it really depends upon decisions that are made globally in terms of emission scenarios. So that's the sea level rise story. I think most people that are interested in these topics know that along the Oregon coast, El Niños are really a major driver in terms of high water levels and erosion events. And we have elevated water levels, anomalous hotspot erosion during those events. And there's a big question in the literature about what might happen in the future with ENSO variability. And some studies have actually suggested that the frequency, at least, of El Nino might actually increase into the future. Some studies show that the magnitude, the magnitude of the events, how strong they are, might modify as well. And that's going to have a significant impact on our waves and water levels, and ultimately the hazards that the coastline experiences. Kaya mentioned that we, experience a coastline that has some of the biggest waves in the world, and that's certainly true. And we also know that storminess patterns have evolved historically, and they may continue to evolve in the future. That may mean a variety of different things in terms of our wave climate. It might not just mean that the waves are getting bigger. They might actually even get smaller, but that might still result in a change in our erosion patterns if the wave direction changes and the wave period changes. So a significant amount of influence of climate change and variability on these hazards that we're talking about. And being here at OSU, I'm contractually obligated to not just mention our chronic coastal hazards along the coastline. I think most of you are hopefully very well aware that we also are just onshore of the Cascadia subduction zone, which means that we're also subject infrequently, but to a very major hazard, the really big one, which was the Cascadia subduction zone earthquake and associated tsunamis, the last of which occurred in 1700. But every 300 to 500 years, science goes, there's the chance of one of these major events that is going to result in significant earthquake shaking, coastal subsidence along the coastline, causing increased erosion and flooding, and then major tsunamis causing significant damage. And this is just a picture of Seaside and a very similar geography along the Japanese coast and the Sendai Plain during their 2011 event, showing what could potentially happen during a Cascadia subduction zone earthquake. I'm going to focus mostly on chronic coastal hazards tonight, but within this kind of framework, it's really the Cascadia subduction zone that sets the geology and the geography of our coastline. It's the reason why we have such a longshore varying coastal landscapes of beautiful, tall, linear sand dunes, coastal bluffs and coastal cliffs, and the kind of basically processes and hazards that our coastline and infrastructure is experiencing. It's kind of set by that subduction zone geology. So one of the things I want to take the time, as was mentioned by Rhiannon, is that I'm currently part of a very exciting and complex study that's really focused on increasing coastal community resilience to coastal hazards throughout all of Cascadia. This project is known as the Cascadia Coastlines and Peoples Hazards Research Hub, or the Cascadia COPES Hub, as we call it. This project is funded by the National Science Foundation, and it's a 5-year effort funded at a very significant amount of resources, and basically involves institutions up and down the entire Cascadia coast, from Cal Poly Humboldt in Northern California to our partners up in the University of Washington. And we're looking at a variety of hazards that the coastline is experiencing, doing a variety of different scientific projects, and really trying to work with coastal communities and to try to increase the resilience of the coastline. So the overall vision of this project is to increase communities' coastal resilience, to protect lives, identities, values through a variety of scientific advancements. We're aiming to try to provide information for hazards assessments, mitigation, a variety of adaptation measures, including planning, policy making, and engineering, but all the time working in close collaboration with a variety of different communities, including a lot of people that are on this call right now. The way this project operates is we have several kind of intersecting teams. We have a bunch of folks that are really focusing on the tectonics and the geohazards associated with Cascadia subduction zone events and doing that work in a very probabilistic sense. We've got a team that's focusing on exposure to inundation and coastal change hazards, and a team that is integrating a lot of that information and really looking at adaptation and increasing community resilience directly. And then a variety of folks also really focusing on broadening participation in this kind of work, having more and more voices being brought to the table, thinking about hazards and adapting to those hazards. And we do a lot of engagement and co-production with coastal communities, as I've been mentioning. So I wanted to give you a couple of examples of that, and variety of ways that we have developed partnerships and are doing engagement along the full Cascadia coast. A lot of this work does, of course, happen in Oregon. We've had workshops, for example, with state and federal agencies focused on the hazards associated with earthquakes and tsunamis, and really kind of bringing people all the way from Northern California up to British Columbia, kind of up onto the same page in terms of where the science is and where things need to go. We've had incredible work done by my colleague Jenna Tilt here at OSU, working with Felicia Almeida Schult and students working with a variety of underrepresented communities along the coastline, doing some engagement about how they perceive and experience coastal hazards along the coastline and ways that we can actually increase resilience of a variety of different communities. Last winter, we had a very large meeting called the Navigating Coastal Hazards meeting in Astoria, Oregon. We're going to have a second one of these in February of 2025. And so if you're interested in these kinds of things, please get together. We're going to be, and again, thinking about community values, needs, and variety of visions of coastal resilience. And we have very direct ways in which this project can actually provide resources and support to a variety of different communities along the coastline. And we have is what we refer to as the Cascadia Community Engaged Research Clearinghouse. I'll give you a website at the end of the talk that you can get on and actually enter some information and to potentially get some support by the Cascadia COPES Hub. But it's really a way that we can actually identify community needs and actually put some resources, students, postdocs, faculty time to try to understand what communities are dealing with and ways in which we can actually increase that resilience. One more slide here about just the Cascadia COPES Hub in general. We've had a variety of ways in which we're trying to actually broaden the participation. We do this directly by having a series of undergraduate student fellowships, and now we have approximately 40 students that have been taking part into this in this fellowship program over the course of the last several years. These are students that come from a variety of different underrepresented backgrounds across a range of dimensions, and typically from non-STEM backgrounds, but they've been educated in terms of coastal hazards science and communicating that science, and they all do get involved in research projects, again, focus on community resilience. If you aren't aware of it already, the Cascadia COPES Hub has a pretty phenomenal monthly seminar series, and everyone's invited. We've had some incredible set of seminars in the past, and a couple of really exciting ones coming up that I'm advertising here in the lower left. We also have newsletters that we partner with other organizations with. We have the opportunity to get students involved in team projects to help with community resilience efforts. And so there's a variety of ways in which we can work with communities, again, to think about increasing coastal community resilience. All right, so enough about that project as a whole. I'm going to now drill down to some of the things that we're doing, actually very specifically in the research group that I'm working with here at Oregon State University, thinking about quantifying our chronic coastal hazards of coastal change and coastal flooding, both now and into the future as we experience climate change. And I'm going to do that by talking about a variety of different proxies for change that we're quantifying. And I'll describe them and talk about how we're quantifying them and how they might evolve in the future. But one of the things that we've really tried to do over the course of the last several years is kind of socialize these products that we're developing with a variety of folks that might be able to use this information for thinking about the future of coastal hazards, thinking about adapting to coastal hazards, thinking about what might happen along the lines of coastal squeeze. And so, for example, one of the quantities that I'll talk about a little bit later in detail is a metric called safe beach recreation hours, and that's basically a quantity that's trying to understand how often waves and water levels are getting close enough to the back shore, whether it's a bluff or a dune or it's armoring, such that we no longer have a usable beach for playing, working, walking along the coastline, etc. And so really, it's a really nice way to kind of quantify this concept of coastal squeeze that was mentioned at the beginning of the seminar. All right, so starting with coastal change, I just want to take a little bit of step back. Up until very recently, the only alongshore consistent statewide assessment of coastal change that we've had for the Oregon coast was a report that was published by the U.S. Geological Survey in 2012 that was basically part of a national assessment looking at multi-decadal shoreline change. I was part of this effort, and it really kind of quantified how coastlines are evolving. And this right-hand plot, this color bar just basically shows the alternating areas along the coast that were either erosional at the time, accretional, or relatively stable in kind of a broad brush sense. This was done in a very nationally consistent manner. But the last data set that was used as part of this effort, again, it was published around a little over a decade ago, was from 2002. So this is now going on about a quarter century in age. It's still an incredibly useful product, but it's now quite dated. And it really, up until this point, has been our only consistent shoreline change quantification for the state of Oregon that we have. But we can see that it is very useful for quantifying areas of kind of hotspot erosion. This is a map of the Tillamook County coastline. We can see that we're having relatively high rates of erosion over timescales of 1967 to 2002 at places like the Cascadia, the Nesquin coastline. We see areas of accretion up near Pacific City, so it kind of matches with our intuition and the experience with people on the ground. It matches with some of the adaptation measures that people have been implementing in terms of riprap revetments along the Nesquin coastline. Luckily, this has not been the entire story. Thankfully, the state of Oregon has the work done by Dogami from John Allen and Laura Gable's group that have been doing a lot of detailed beach monitoring along various aspects of the Oregon coastline. And so they have had in some areas some fairly up-to-date high resolution shoreline change estimates. Again, this is part of the central and northern Oregon coastline. But this kind of data that they've collected is, it takes people going out on the ground and, collecting data with beach buggies or GPS backpacks, et cetera. And it's fairly expensive and time consuming. And so one nice thing that is just starting to happen now is we're actually now able to extract shoreline positions from the satellite record. And we're able to do this pretty much anywhere we want globally, going back to the beginning of like the Landsat satellite record, which starts in 1984. And so this is now, we have the ability to extract relatively high resolution spatially and decent and very good temporal resolution shorelines for anywhere along the Cascadia coastline. And now I'm showing all of Oregon and the Washington coastline. And this is data that's extracted from 1984 to 2024. And we have now a very much up-to-date shoreline change analysis. And so this proxy that I'm quantifying here is, you can think of it as kind of the wet dry line during the highest tide of the day. And we're seeing how that's evolving over time. And as the beach erodes, we're going to have shoreline change rates that are negative. And as the beach accretes, we're going to have shoreline change rates that are positive. And we can see that over the full Oregon coastline, surprisingly, perhaps, about 55% of the coastline is accretional during this period, and about 45% of the shoreline is erosional. Now, of course, it's those 45% is where we're having problems, and that's where infrastructure is in jeopardy, potentially transportation corridors in jeopardy, and these are the problems that we need to be thinking about. Okay, but it's really exciting now that and this is work thanks to graduate student Mohsen Taharkhani in my lab group, who has just produced this really spectacular data set for the Oregon and Washington coastline. All right, and this is just a little bit of an advertisement of work that's going to be going on in the next couple of months. We now can actually take that shoreline change data, put it into numerical models that actually help us calibrate those models. And the idea is to then move forward and actually make some predictions in the next couple of decades about what we might expect with those sea level rise projections that I mentioned earlier. And so this is work that's in progress. So check back in with me. That we're also able to calculate now based upon work by another PhD student that just finished in my group. Her name is Meredith Leung, and she finished in this past June of 2024. And what Meredith did is she calculated what we call the total water level. So that's the elevation of the tide, plus what the waves are doing on the coastline, plus any storm surge we might have, water level anomalies due to El Nino. And I promise this is the only equation that you'll see here tonight during this webinar. But with making estimates of how high the water level gets kind of on an hourly basis based upon observations we have, we can actually calculate things like how often the water is getting up and over our dunes, like the movies I showed at the beginning. So we call that overtopping, how often that waves and water levels are banging into things we care about. So that's collision, potential for backshore dune and bluff erosion. And then also this unsafe beach hours, how often the beach is basically just not accessible to do the things that we want to do on it. Okay, so Meredith has ways to do this for the historical time period, and she's developed some techniques to be able to move this forward into the future. We can incorporate those sea level rise scenarios that I mentioned earlier, somewhere between 1 foot to 5 feet by the end of the century. And we can make these calculations of how much these hazards, these water level hazards, will change into the future. And so what I'm showing here in this first set of plots is just one simple transect just north of the inlet to Tillamook Bay. So this is the Rockaway area. This is a relatively famous area that has a riprap revetment in it that is not accessible at a lot of high tides right now. We can actually see that we have a significant seasonal variability to these hazards that we're quantifying. So clearly in the summertime, when the beach is relatively wide and the waves and water levels are relatively low, we actually have very little problems. But it's in the wintertime when we get these king tides and high waves that we actually start having impacts. So waves banging into the back of the armoring, causing unsafe beach hours. And then adding the sea level rise to that, this is just a single transect, we can see how these trends will change in the future. So this is an area that only overtops a very small number of hours per year in today's climate. But at the end of the century, with a particular sea level rise scenario, we can actually quantify how much increase in overtopping hours that we might actually get. And what Meredith has done here is she's calculated this at monthly scale, at the annual scale, and even at the decadal scale. And the really nice thing about this kind of information is it's useful for thinking about areas that maybe not haven't done much in terms of climate change adaptation now, but at some point in the future when these hazards are beyond what they want to, the people that are living in those areas or managing those areas beyond a certain threshold might think about certain adaptation measures. Okay. And so we're able to make those kinds of calculations, not only at single transects along the Rockaway coastline, we're able to do that everywhere throughout the entire coast of Cascadia. And so this is another set of plots now where these circles basically represent averages over the spatial scale of littoral cells. So many people know what littoral cells are, but basically it's the area between adjacent headlands. So think of like the Beverly Beach area between Yaquina Head and Cape Foulweather as a littoral cell. And so Meredith has made an average of each of these hazard quantities at each of the littoral cells within the Pacific Northwest. So what we've done this is for a no sea level rise, so basically the present day scenario. We've quantified this everywhere. And basically what she's found is that even though we know that we have some pretty significant problems along the central and northern Oregon coastline, compared to some coastlines up in the northern Washington coast, up on the Olympic Peninsula, and even some areas down in Northern California, the amount of time in which we have unsafe beach hours or collision hours is actually less right now along this section of the Oregon coast than it is in these other areas. So that's kind of a first piece of takeaway information from these plots. The next thing is that Meredith was able to do is add different sea level rise. She picked 3 scenarios: a low sea level rise of a little bit over a foot up until about, maybe 3 to 4 feet with the high sea level rise scenarios. And she's calculating now with this different color bar over here, again, spatially average, but it's basically the differences in these hazard metrics. The left-hand set of circles is this unsafe beach hours. The C represents how often waves are banging into backshore features, the collision hours, and the O is the overtopping. And we can now see areas that are really starting to increase in terms of hazards going forward. And you actually start seeing some red dots along large stretches of the Oregon coastline here. And so that brings me to the next and last thing that Meredith did, and she did this again at the all of Cascadia scale, making averages over each individual littoral cell, is she wanted to think about really what does this mean in terms of hotspots going forward. And so what she's done here is combined all of those 3 metrics into a single hotspot metric, and that's represented by these circles now. But she's normalized by how bad the hazard is in today's climate. And so what she's now showing is basically the relative increase of these hazards going forward. And what really shows up now is that even though areas that I mentioned in the central and northern Oregon coastline, we are experiencing hazards in today's climate, but maybe not as bad as places in northern Washington and northern California. But these are areas that are actually going to have a significant increase in hazards relative to how bad things are today. And what Meredith has pointed out is that these are potentially places that are not thinking about adaptation. They're not thinking about beach squeeze as much right now, but they might have to relatively soon with these different sea level rise. So that becomes important in terms of thinking about coastal adaptation. All right, so I've been showing you a lot of plots at kind of the Cascadia scale with a lot of spatial averaging that's taken place. And so that might not be as useful if you're thinking about what about the particular beach that I like, and I go to most often. And so what we've also started to do is make similar products at a much more local scale. And here's an example of the same kind of metrics quantified for approximately today's climate, and then for a couple of decades into the future, looking at kind of a medium sea level rise scenario. This is Cape Lookout, Oregon, one of the more popular state parks. Obviously an area that I think many of us know has been experiencing erosion hazards over the years. And we can actually quantify the potential increase of these unsafe beach hours, collision hours, and overtopping hours at the scale of kind of every couple 100 meters along the Cape Lookout shoreline. So this becomes important in terms of what OPRD is thinking about doing in terms of managing the campgrounds in this area. They installed a dynamic couple revetment in this area several years ago that potentially needs to be maintained. And so this work, we've started to, as I said, make these kinds of products. We've served this particular kind of story up on a story map collection that is a part of a larger group of output from the Cascadia COPES Hub. And I encourage you either to look around at our website or to scan this image in the lower left to to take a look at these story maps, because it's a great way to kind of distill a lot of the information that we've been talking about, and make it hopefully in a format that is useful to a wide variety of folks and decision makers. And our simulations in particular project that growing beach safety and erosion hazards, so coastal squeeze, during the 21st century will be particularly worse along the southern end of the beach and directly fronting the campgrounds, which was a relatively predictable result from this kind of analysis. All right, so I'm going to just give a couple of key takeaways from the analyses that I've shown thus far. I started with the movie that's playing right now. This is the kind of thing that we experience relatively infrequently now, but these kinds of hazards, shoreline change, flooding, backshore erosion, and reducing beach safety as well, this coastal squeeze is all going to increase throughout the 21st century. We have the ability to at least make some estimates about how bad that will get in the future, how it's going to vary along shore, and based upon the sea level rise scenario that we care about, we could quantify where things are going to get bad first. And the idea here is that quantifying the range of possible future hazards can ideally help Oregon's coastal communities prepare and adapt to climate change. And that's the next phase of the presentation that I'm going to go to now, by starting with just kind of the suite of adaptation options that are available to coastal communities. And this is not necessarily comprehensive, but basically it shows kind of the range of options, many of which have been implemented already along, if not Oregon's coastline, the West Coast coastline, if not the country's coastline. There's a range of kind of protection options that involve kind of hard, kind of gray engineering solutions like seawalls and riprap revetments. These have been typically what we have implemented along the Oregon coast, and was mentioned earlier by Kaya. There's a range of other approaches in terms of nourishing beaches and dunes, dynamic cobble revetments. There's a couple of projects in Oregon and a handful of projects now along the Washington coastline. And then of course, there's also a range of policy options in terms of maybe changing our land use planning as well. There's a gradient here in terms of resisting kind of natural forces of nature and sea level rise through a kind of potentially evolving with nature, and kind of taking how things are going to be changing into account as we think about our adaptation options. So that there's a wide range of potential tools out there. Okay, and so we've been trying to think through what the future of the Oregon coast might look like now over the course of several projects over several years. And we're doing this using a tool that we refer to as Envision. And that's basically a relatively simple numerical model that's kind of in a GIS framework. So it's spatially explicit. It incorporates basically simple models that are very much like what I just told you in terms of the ability to quantify shoreline change, sea level rise, total water level variability. But the thing it has is actually it has the ability to quantify where the built environment is, where transportation corridors are, so structures, developments, population centers. And it has allowed us to start, quote unquote, playing some games by identifying some potential policy scenarios and looking how the coastline might evolve if decision makers start implementing a variety of different adaptation options. And these, like much of the work that's done with the Cascadia Copes Hub, this work has been primarily done with a long-term, deep community engagement, working with advisory councils, coming into communities, asking people about their visions for the future of the Cascadia coastline. And so these are certainly policy scenarios that we have not just come up with ourselves here at Oregon State. We've really tried to listen to and hear what people in the coastal communities have said about what they're thinking about. The general framework here is for assessing a variety of different resilience strategies, is to kind of identify these policy options and strategies. And I'll talk a little bit more about those in the future, to do the hazard modeling that I started this talk with, and then to quantify some resilience metrics. And there's a variety of different ways that we do this. I'll kind of breeze through a couple examples. And the idea is that with some quantitative resilience metrics, we can actually look at trade-offs and differences between a variety of different options about what the coast might look like based upon our decision making. Okay. And so again, as I said, a lot of these policy scenarios came out of a lot of long-term conversations with different communities. We always wanted to kind of compare and contrast with what the coastline looks like now. So we have a baseline scenario where we basically maintain the existing kind of backshore protection along the coastline, but don't kind of add to it. We have a protect solution or a protect policy scenario narrative where basically policies or decisions are implemented that involve resisting environmental change in order to protect existing infrastructure. And so this is, example here is building or strengthening shoreline armoring, constructing riprap revetments. We also have implemented a realigned policy scenario in which we are looking at policies or decisions that involve changing human activities. And one example policy scenario here is hazard zone development restrictions. And so I'm going to look at these as kind of example end members. We've looked at a variety of different policy scenarios, and we can talk about that at some point as well. Just again, to put that all together, we've kind of complicated our lives, but not only looking at these chronic coastal hazards that I've been talking about most recently of kind of sea level rise, changing shorelines, changing water level hazards, but also incorporating Cascadia subduction zones into that and thinking about mitigation, adaptation options to reduce the impacts of those. We're incorporating, as I said, climate change through sea level rise scenarios. And the last thing that we're also trying to do is to think about ways that we potentially could target some of the scenarios such that we might prioritize various vulnerable populations rather than just have the adaptation options kind of sprinkled across the landscape blindly. All right. So let me give you some concrete examples here. So using the same set of kind of total water level modeling tools that I mentioned earlier, incorporating sea level rise and our total water level modeling tools, we can set up simple rules for when coastal communities might implement coastal armoring. So obviously the armoring is in place along the coastline to protect backshore erosion. And so we know at certain time periods where armoring exists along the landscape. So here's a 2020 estimate of riprap revetment along the Rockaway coastline, and with simple rules about when we might trigger new infrastructure to develop new backshore protection structures, we can actually see how that might evolve into the future. But with these additional red areas, we now are with a particular scenario going forward, and these are all Goal 18 backshore protection eligible lots along this landscape. We can see a future in not too many decades, potentially with certain sea level rise scenarios where we might have a significant amount of armoring along that coastline. And so what are the trade-offs that we might want to look at is, again, kind of thinking back to unsafe beach hours or beach accessibility. We could actually quantify along the coastline how often, again, we can actually walk, have days where we can actually walk along a coastline. And obviously in a situation like this where there's armoring and waves and water levels are banging into the armoring, it is no longer safe. So that would be determined as a limited beach access. We can quantify that in the present day, and we can also quantify that out into the future with different scenarios, like the baseline. Even we're just allowing armoring to increase going forward versus realigning, actually moving, implementing a managed retreat scenario. We're actually moving some infrastructure off the landscape. We get a very different scenario in terms of beach accessibility. And just looking at that in terms of quantitative plots that can see the evolution of the percent of how much of the shoreline over this particular littoral cell is hardened. We see how that evolves into the future. And we also see the decrease in terms of beach accessibility. And so we have trade-offs associated with certain, if we want to protect backshore infrastructure, we're going to do exactly what was mentioned earlier. We're going to reduce the usable beach. We're going to have that potential beach squeeze. And there's potential ways to avoid this with beach nourishment, not armoring the coastline, managed retreat. And these are the kinds of policy options that we're trying to look at in this modeling framework. All right. I want to just very quickly mention just a couple of other things that we're trying to do now and moving this work forward. I mentioned briefly that we're incorporating not only these kind of chronic climate change induced hazards like shoreline change and flooding, but also what happens if we, over the course of the next century, we actually have one of these CSC induced earthquakes and tsunamis. And so not only can we calculate the exposure of the built environment to those hazards now or whenever these events might occur, we can actually condition the results of those hazards on things like economic class, resident age, ethnicity, owner status, whether it be own or rent, because it's those metrics that really kind of dictate the vulnerability of populations to these hazards. As I said before, one thing we might want to do is actually target some of our adaptation options to more vulnerable populations. And just as a couple of different examples of that, if we are worried about, well, if we implement a protect basically policy scenario, like I mentioned earlier, by implementing armoring, that does a really nice job of reducing erosion into the backshore. It doesn't do such a great job of reducing flooding. However, if we actually move infrastructure off the landscape, we can actually reduce the number of flooded buildings quite significantly. We can also think about that in terms of who is being impacted from the various income ranges, ethnicities, et cetera. And so that's what I'm showing in these next couple of panels. And I not really worried too much about the numbers. It's just kind of the relative differences between these numbers. This is the protect scenario in pink and the realign scenario in green here, showing a very different impact on different populations based upon these two very different potential scenarios. And then finally, these two different shades of green represent differences if we actually target the policies towards, say, low-income households. We can actually reduce the impact by, on the order of about 7-8% of the number of houses that would be damaged to low-income populations. And so that's one potential tool that we might have in the toolbox, is actually targeting some of these adaptation options to different populations along the coastline. All right, so some key takeaways from this aspect of the work. Coastal systems and communities, of course, they're facing inevitable change, as I mentioned throughout this talk. But a lot of the decisions that we make right now can dramatically influence coastal community resilience and even the equity associated with the hazards. Under some of our existing policies right now, there's going to be severe Cascadia subduction zone, earthquake, tsunami hazards impacts, as well as climate change impacts into the future. There's not much we can do about that in general. But these policy scenarios really range in terms of their efficacy, in terms of reducing the impact. And our ability to target to certain populations might be something that we want to consider as well. And then the final point here is that exploration of idealized adaptation pathways, like I've been talking about, can hopefully highlight some non-intuitive feedbacks between the natural and human systems to help us make better decisions, kind of thinking about what the future of the Oregon coast might look like. And I think I'll stop there. One more reminder that a lot of this work has been kind of couched within this really nice NSF project, the Cascadia Coastlines and Peoples Hazards Research Hub. Please feel free to reach out to me or just get on our website and explore. It's a really fantastic project with a lot of great researchers, students, postdocs that are all interested in community resilience along the coastline. And with that, I'll end. Thank you.
Great. Thank you so much, Peter. If you have a question, feel free to either drop it in the chat box or you can use the Q&A box. Or if you would like to ask your question directly, go ahead and raise your hand and I can unmute you. All right, we have a question from Diana.
Hey, Peter, this is Diana Turner with Friends of the Dunes at Cannon Beach. Last Thursday, I was at a planning commission meeting and I was opposing a new riprap revetment in front of a single lot in Cannon Beach, Tolivana neighborhood. And one of the counselors, after I gave testimony, asked me if we're going to lose our beach anyway. And he said that he feels as though it's inevitable with growing waves and storms that we are going to lose the beach. And so is it fair to try to go with a nature-based solution like a vegetated clay burrito, which we have 5 lots that have been protected for over 2 decades in Cannon Beach with that erosion control measure, when it's not a guarantee, and they feel that a riprap revetment is a guarantee. And he said, I would hate we're going to lose the beach, but do we have to lose a house also? And another commissioner seconded that sentiment. And they asked me, so what are people saying? When are we going to lose the beach? Are we going to lose the beach? What's really happening? Big question, I know.
Yeah, Diane, I heard most of that. For some reason, it froze a couple of times and I missed a couple of parts of that. Hopefully you can hear my response.
I can.
Yeah, okay. I think, first and foremost, beaches have retreated over the course of the Holocene and with sea level rise over 10,000 years, as we just had natural shifts in water level, and we've always had beaches in front of our kind of backshore features of dunes and bluffs, et cetera. And so kind of the natural system is that the landscape just kind of retreats backwards, kind of depends upon the geomorphology. But in a very natural system, say it's a dune back system, that dune, unless there's incredibly high rates of sea level rise, that's going to just move kind of up and backwards with sea level rise. And that's sort of a kind of a geologist's explanation of what the situation is. And we might have lots of situations along some of our undeveloped state parks where that might actually be the case, where we have low-lying barrier spits in front of some of our estuaries that might be able to just kind of retreat backwards. The issue is really kind of happens when you have infrastructure that you want to protect, and we've kind of fixed the shoreline in place or the backshore in place by either homes, businesses, roads, etc. And so then if that infrastructure wasn't there, again, it's kind of depends upon the geology of the situation, but that beach and backshore could naturally just evolve. So maybe a little bit of semantics here, but the all is not necessarily always lost in terms of even with sea level rise, we could still have beaches naturally. What happens obviously when you put that you harden the shoreline and you don't let it move back, you don't let the backshore move back, and sea level does rise, and you do nothing to augment the sediment in front of the backshore that you're protecting, then you get the situation of beach squeeze. And that's what we've been really trying to quantify, is the timescales associated with when it becomes a problem, when we get this situation of unsafe beach hours beyond what is kind of acceptable to a particular community, or even the homeowners that are trying to do the protection to begin with. And so it really kind of depends. But I think the answer that you're going to lose the beach anyway is not always true. If you hold the backshore in place and sea level rises, then eventually, and do nothing to the sediment budget, then the answer is yes, you will lose the beach eventually.
Right. The community is just starting to talk about this in a real way, and the idea of planned retreat has never really been said aloud at these meetings within the community. And so they are looking at it as, we're going to keep this house here and we want the beach. And is that a possibility? And what's the time frame? So I think this community is asking for the type of work that your group is doing. And in fact, at this meeting, at the end of the meeting, they asked for, some sort of education, because they do realize that this is getting tricky And there is a growing movement to ask for riprap to be taken out of the comprehensive plan, the Fort Dune management plan, as an option. So in Cannon Beach, at least, this is becoming something that people want to dig into.
Yeah. I mean, I guess I just will say that in many parts of the country slash world, that scenario that you just mentioned is what people are after as well, keeping the beach and also protecting the backshore, right, during the big events and the storms. And they do that. The typical solution for that is beach nourishment, and these are typically large projects where sediment is basically borrowed from a source. Oftentimes, it's in an inlet or it's offshore, and it's placed upon the beaches. And it's expensive. It's got to be done over and over again. And so this is kind of the classic, North Carolina coastline solution. The Netherlands does this, et cetera. Unfortunately, it's not a great solution here in Oregon for a variety of reasons. We don't have a lot of infrastructure to do that kind of work. It would be incredibly expensive. We have a very small weather window to actually, if we did have an offshore source of sediment, to actually put that sediment back on the beach. But it would just be incredibly expensive. So that what the people you're talking about have been asking for is something that a lot of people around the world are asking for. It's just a little bit more difficult in our situation, fortunately.
Well, and that's the classic. You want your cake and to eat it too, right? Thank you.
I have a question. So going back to your points on the demographics of who's being impacted by these coastal hazards, um, you mentioned lower income folks will be, but do you have any other sense of what other demographics are of the most vulnerable populations?
Yeah, it's a great question, Kaya. And I went relatively quickly through those plots that had very small text on them. And it was a reason for it is because it's work that's really hot off the press, and we're still kind of working on the details of it. It's one of the questions that this PhD student Meredith Leung asked, and we're still trying to work on kind of finalizing that work. And so I don't want to say something emphatic when we might go back and change some of the details of the numbers. But we're really looking at not necessarily just which demographics are being impacted, but are these demographics that we already know are vulnerable to hazards, when they occur. So low income renters, maybe very old and very young. These are the demographics that have just been shown through countless studies to be vulnerable to different hazards. That's what we're quantifying the relative impact on those populations right now. And so it's a work in progress, and how would I get back to you in a couple of months?
Maybe a good topic for a future webinar. Dig more into that.
Sounds good.
And again, if you have a question, go ahead and put it in the chat or the Q&A box. Or you can raise your hand and ask it directly. While you guys think of your questions, I'll ask another. So you mentioned the idea of safe beach hours for safe beach recreation. Do you have any sense of how this will affect surf breaks or things like rocky intertidal, some of the other activities that you might do on the beach?
Yeah, now you're asking even harder questions. From the influence on surf breaks, it's a little bit hard because the morphology is evolving constantly. So nearshore sandbars are often the places where waves are breaking and are causing surf breaks, and those systems will continue to evolve as sea level rises, and as the usable beach shrinks. You will ultimately potentially get some beach coastal squeeze associated where those sandbars are. You might steepen the beach, and then things might evolve that way. It's a pretty difficult thing to quantify. For breaks that are more fixed based upon geology, like some of the rock reefs, not just sandbars. Those are held in place, and with sea level rise and changing patterns of storminess, the models that we use could potentially illustrate where breaking patterns will evolve, because the models that we use for a lot of these analyses do propagate the waves across the bathymetry, and we do know have estimates anyway of where the waves are breaking. And so if that, the quantities of waves breaking over certain areas because they're getting deeper and deeper evolve, that might potentially impact some surfing as well and some recreation.
We have a good question here from Jan in the chat. Do the unmodified sandy shorelines of estuaries respond in the same way as ocean beaches?
That's great question. Yes and no. From a coastal squeeze perspective, in some sense, estuaries might even be a little bit more of a nerve-wracking situation, because in many of our estuaries, at least in the Oregon coastline, it's not too far past like today's high water line where we actually have relatively steep slopes. And so with sea level rising, kind of that area, that kind of back shore of the intertidal could get inundated relatively quickly. And the major difference is, of course, the energy climate, right? So the outer coast is significantly impacted by the huge wave climate that we have, and that causes not just tides and storm surge, but also waves are pushing water levels up along the coastline. In the estuaries, the energy is a lot more reduced, and so it's really from a function of how much inundation we might have, how much land we might lose. Looking at sea level rise only is probably a way we can actually quantify that. Because of the different energy climates, the models that we would use to quantify coastal change would be slightly modified, but we could still make estimates of how much basically land would be potentially lost with different sea level rise scenarios in those backshore areas, those estuaries. However, it is the geography is more complicated, more sinuous, and it's a little bit more of a complicated thing to do. So we haven't focused on the estuaries as much in my group as we have on the outer coast, but there's lots of other groups that are doing that kind of work.
Oh, Jan has a follow-up question. Will sand spits disappear?
Yeah, that's a great question. This is we don't have like the kind of classic barrier islands that a lot of kind of East Coast, Gulf Coast situations do. Our barrier spits are a little bit typically wider than those, a little bit more robust, but I might have showed an image in one of the slides of Neathart Spit in particular is a relatively thin retreating barrier spit in front of Neathart's Bay. And I think that area has been eroding at a rate of about 1.5 to 2 meters per year, at least kind of down by Cape Lookout, the headland itself. And so disappear that's a big statement, but I think there's a pretty high likelihood that Neathart Spit will actually breach. It's really difficult to predict when that might actually happen. I know that the elevation of the dunes has been reduced significantly over the last couple of decades as we've eroded through some really high dunes that existed there. And so what happens is you get kind of a feedback where it's easier to overtop the dunes now than it was a couple of decades. Then that causes potentially more scour in the backshore. So I think that's one area where I'm not predicting that Neathart Spit is going to disappear by any stretch of the imagination, but I think that we can have a breach there, and that's going to change the hydrodynamics of Neathart's Bay to some extent. In terms of other, we have a couple of other, sand spits that are, I think, similar to Neathart Spit in particularly if you go further south along the Oregon coastline, some even kind of thinner ones, and those, certainly breaching is always a possibility and overtopping. But some of the bigger, more robust ones, I think we've got some decades before that might happen.
Not too long in the span of things.
No.
We have a question from Charlie in the chat. How well do we understand the value economically and culturally of our beach? We often speak of the cost to homeowners, but how well do we understand what we are losing in the coastal squeeze on the public resource?
Yeah, this is a great question. And yeah, Steve Dundas really should be the person answering the question, Charlie. So thank you for that. But yeah, Steve is a environmental economist that's here at OSU and a colleague for the last several years. We've worked on a variety of projects together, really trying to value kind of the variety of ecosystem services that beaches and dunes provide to Oregon communities. And so, that range of ecosystem services include things like coastal protection to the back shore. It includes things like aesthetics, how beautiful, the area is. Includes things like habitat of, a variety of species, including some of our endangered species. And then obviously recreation is a big part of that. And so one of the things we've tried to do is quantify each of these individual ecosystem services individually, and then to combine them and think about, very similar kind of toy games that I mentioned earlier in terms of thinking about different policy scenarios. What if we actually manage the coastline slightly differently going forward, manage more for recreation? What would that mean for the overall portfolio of ecosystem services? And that work is really just starting to kind of come online. So a lot of what I've been talking about is still in progress. But Steve has some studies. I can't give a dollar number, but he actually has done some really nice economic studies that can quantify how much having the ability to armor the shoreline actually modifies the price of the actual home that has that ability. And there's a certain dollar number associated with that, and you can imagine that it actually varies depending upon what the erosion rate is, and even what the elevation of the home is at. It's there's more of a premium on that ability to armor if they're at lower elevation, more susceptible to erosion. But then it turns out, according to Steve's work, that once that armoring actually has taken place, that the actual value of the homes are slightly reduced. So these are kind of broad. I'm not talking about any specific development or home. These are broad brush estimates over large spatial scales. But it's just a very interesting result that the ability to armor increases the cost, the price of the home. But once the actual infrastructure is that backshore protection structures are in place, the riprap is in place, it actually has a slightly negative impact on housing prices. But we should give one of these seminars and answer those questions directly.
Yeah, definitely a good topic for a future one for next year. Kristen has a couple of questions here. What will ultimately happen to the rip-wrapped Shorewood RV park on the Rockaway shore? Yes, the coastal squeeze will soon not permit walking past that place on the beach at high tides, but what impact will the wave and sand action have as things continue?
Yeah, so
and then go ahead.
Sorry, the follow-up question. Human-made reef structures. Ooh. All right. Well, I mean, the first question is, that's really kind of what we're trying to quantify is how often that particular property, for example, but many others that are similar to it, how often we cannot, just in any given day walk along the coastline, right? Because you might actually get impacted by waves banging into the base of that riprap. As sea level continues to rise, waves will start to potentially overtop that riprap and cause flooding into the development that's being protected in the back shore. And just as the water levels rise, that's just an obvious thing that might happen. What might start also happening is, some locations you get kind of end effects, and there's a variety of reasons why that happened, but the easiest way to think about it is that there's an erosion issue along that stretch of coastline. That's why the riprap it was placed to begin with, is to slow down that erosion or stop that erosion. That didn't change the process, the reason why waves and water levels are continuing to erode the coastline. And so the areas adjacent to where that riprap is, they continue to erode, right? And you might get a little bit accentuated scour in the immediate edges of that existing structure. And so I know there's been a new project that's been implemented. I don't know if it's immediately to the south of Shorewood RV Park. Rhiannon might know better than I do, but I know that there's another adaptation option that has been implemented along a stretch south because they were starting to get impacted by that just erosion kind of continuing to march on. There's a stretch of coastline just north of Willapa Bay in Washington that has, pretty significant riprap revetment, and it's a piece of property that is almost an island now because erosion has continued almost around it on either side. And so that would potentially continue with basically almost no beach in front of it. I mean, no beach maybe on average, but certainly during the summer we have significant swings in terms of sediment availability, and so there's a lot of just natural variability, and sand comes and goes with different cycles. But in general, you're just moving towards a situation of having no beach in front of that structure. In terms of this human-made reef structure, there's a lot of very clever adaptation options that have been developed over the years. Armoring, I showed some pictures of some of those. They're in lower energy environments, people have tried submerged reefs, and they might do a really nice job of breaking waves and reducing the wave climate, reducing erosion and flooding. But it is really a hard to imagine option for many Oregon outer coast situations, primarily just because the cost would be so high to develop it, to place anything that would actually withstand our wave climate. This is one of the most significant wave climates in the world, and so a lot of the more clever options that have been used in lower energy environments really are just not. They could potentially be developed here, but the cost would just be astronomical, literally.
Any last questions? I'll point out Charlie put a link in the chat to check out a project related to those man-made reef structures. And just a reminder, we will have a recording of this webinar available on both the Surf Ride of Oregon and the Oregon Shores YouTube pages, so you can watch again or you can share it with your friends. That should be up in the next few days. And it looks like there's one more question. In 2019, Merkley and Wyden introduced legislation to create a grant program, $50 million per year, for living shoreline protections using natural materials. Have any shorelines been implemented yet through this legislation?
This is a question for Rhiannon. Hopefully.
So like Peter said, a lot of these nature-based solutions are not appropriate for the Oregon coast. So in other parts of the world, in Virginia and in the Gulf Coast, there are a lot of living shoreline protection structures, and even in Virginia, that is their preferred by the Virginia government. That is their preferred method for shoreline protection. But along our coastline, a lot of these living shorelines just wouldn't work. They may work in estuaries or in very low energy environments. So they're not necessarily something that we should discard altogether. But on the open coast, we're probably not going to see something like a living shoreline being implemented. It's just not the right environment. We don't have naturally occurring marshes on the open coast here, or oyster reefs or anything like that. So there are some parts of those projects that we could use in maybe hybrid structures or non-structural solutions. And we are working with Surfrider on some projects like that and providing guidance. But strictly nature-based solutions and strictly living shoreline projects are probably not going to be the best solution for most of our coastline.
Could an intact dune system not be considered a living shoreline? Question from Charlie.
Yeah, I mean, this is a policy, how to interpret that particular grant. So I don't know the details. I mean, from my perspective, it sounds like a winner, but I don't know if Rhiannon knows how people are interpreting that money source.
Yeah, I would have to look further into that to see if anybody has been interpreting it as including dune systems. I mean, that I don't see why it couldn't be included as a non-structural solution, but yeah, I would have to look into that funding source in particular.
All right. Well, if there are no other questions, thank you, Peter, for a very informative presentation with all the slides this time. And again, recording of this will be emailed out. It will be posted on our YouTube channel. And we hope to catch you at the webinar series in the new year. So thank you all for coming, and we'll see you next time.
Thanks for having me. Thanks, guys.